Energy and energy in the form of electricity is really the foundation of basically everything. The first question is, okay, why isn't energy cheaper? Like what drives the fundamental cost of energy today? A lot of the cost of energy is in the delivery of the energy. If you look at the average distribution line in the US, its utilization is far below 50%. But the entire system has to be built for peak. There's a ton of extra capacity sitting there. You want storage to fix that problem.
Welcome, Justin. We're so excited to have you here. Thanks for coming to chat with us on the pod. Justin Lopas has built his career at the frontier of American Dynamism. You've worked at SpaceX and Anduril, and now as the co-founder of Base Power. At each step, you've tackled some of the most important engineering challenges facing our country: defense, space, now energy. Today, you and the Base team are working to transform America's power grid with distributed energy storage, a problem that is as critical as it is complex. Backed by A16Z, we're very proud and happy investors in Base Power. You've become the leader in the Texas energy ecosystem very quickly to expand beyond that, and ambitions to scale nationwide. So we're super happy to have you here today.
Yeah, Erin, thanks a bunch, Ryan as well. Really great to be here with you both. Had an internship first semester of my sophomore year at SpaceX, and had the really good fortune of working with some really truly excellent people there, and being exposed to the aerospace industry and all the really cool things that
what
Elon
drew
and
you
the
to
team
SpaceX at the time? What was going on?
So, it's like a really hard technical problem. The technical challenge of rocketry was like clearly higher than automotive. Obviously it's different in many ways. Not to say cars are simple or easy by any means.
I think
like,
it's
that's
fair
not
to say
the case.
SpaceX is more complex.
It's a little harder on the technical side. And so I was like, wow, that's pretty cool. And maybe the coolest thing I could do with my degree, so to speak. This is, it's very early in my educational career. And because I studied mechanical, I really wanted to see a bunch of different problems, so I ended up doing internships in oil and gas, in automotive, at SpaceX, in aerospace, and then actually at a financial services firm in Detroit called Quicken Loans, now Rocket Mortgage, previously Quicken Loans. And so basically, I was like, hey, I wanted to get a bunch of different experiences, and ended up going back to SpaceX.
I mean, it was
full-time.
a really cool time. It was 2016 at SpaceX, the Falcon program. Like, what was that like?
Yeah, it was super cool. So when I started full-time at SpaceX, it was right when the company was transitioning to building and then ultimately launching about a year later the human-rated version of Falcon. So Falcon, for many years before that, had just flown satellites and done a great job and been very economical and was groundbreaking, in and of itself, of the whole propulsive landing and all that. But at the time, they were focused on building a human-rated variant and basically redesigning the whole rocket. This is the Block 5 variant that folks might have heard of. And my team and I ultimately were responsible for building the thrust structure they call the Octaweb. It's this big aluminum machined and bolted together assembly. And I was working on manufacturing engineering. So it's kind of all of where technical and operational meet. And that's, I think, as you'll see as a theme throughout the discussion here, where technical, economic, operational problems meet. That's what I personally really like. And that was why I found myself in manufacturing when I started there. Later on at SpaceX, moved to the Starship program. So went down to what is now Starbase, but is actually Brownsville, Texas, as part of the landing team, so to speak, and built out that whole site until the first launch. And kind of from overgrown field to rocket manufacturing facility, that was my time there. And it was a really awesome experience. Learned a ton working alongside Elon and his executive team, and just had a great experience overall at SpaceX.
What were some of the hardest or most interesting engineering challenges that you guys had to solve?
Yeah, so I mean, a lot of it, at least on the Starship side in particular, was around how do you build something of this physical scale. If you've ever seen a Starship up close, it's a rounding error to about a building. It's like a skyscraper, essentially. And it's like, how do you build a skyscraper that flies? How do you build a lot of them very quickly? And how do you do it without the traditional sort of build a skyscraper structure, right? So it's like if you're building the building that we're in,
you have scaffolding.
You have scaffolding, you have concrete. You don't really care about weight for the most part because it doesn't need to fly. And all of everything about that is way harder when it becomes something that flies. So like, for instance, the rocket is made of very, very thin steel. And so it's like thinner than a can, like a aluminum can, meaning like the wall thickness with respect to the diameter is thinner on Starship than it is on a can. And so you can imagine, like, how do you get people up to do the welding and installation? How do you do weld inspections? There's miles and miles and miles of weld on there. A lot of my manufacturing engineering work was around welding, weld processes, and how do you have, lift things up safely with the crane. It's a very operationally intensive challenge. So
I think what's interesting is, and especially at SpaceX at this time, I was just trying to pull up some numbers.
Yeah.
It was less than 20 launches a year, and now we're, I think, at the rate of approaching 180 in 2025.
Yeah.
So the company going from a transition from an engineering company, constantly iterating, to a sort of rate manufacturing.
Yeah.
Can you talk a little bit about what that looks like? What are some of the design decisions that go into it? And particularly for you, the manufacturing engineering side, like how do you think about a product to ultimately scale?
Yeah. Elon said this, so me saying this maybe isn't super groundbreaking, but prototypes are easy comparative to production, right? And in my lived experience, the reason for that is you can do anything that's one-off, and you can cut corners, do some heroic efforts, have the engineers physically build the product because they know about it from a design perspective. It's a whole other ballgame when you need to do it repetitively with people that did not design the product, and be able to do it at scale. So a ton of challenges there. On the Starship side, again, you can build a prototype of one unit of the Starship and manually weld it, but how do you avoid having the manual errors in welding when you're doing this repetitively many times over? I think those are some of the real big challenges, and they're both technical and operational. I think a lot of folks from the outside, and engineers like myself, you'll think about the technical challenges associated with, okay, how thick does the steel need to be? How cold worked is it for yield strength, et cetera? The real challenge is, how do you make a process that is so repeatable that you can pull the human out of it and automate it, or that you can delete altogether, right? There's this concept around simplicity in engineering that I think you don't necessarily need at the prototype scale, but you really, really, really need at the production scale, which is, how do you remove processes, remove parts, remove remove various different pieces of the puzzle.
Not to put you on the spot, but is there like an example of something that you deleted or changed about the design that you could share based on how you knew it had to be manufactured at scale?
Yeah, I mean, one of the big things that I'd worked on on Starship was, so imagine, like, when you look at a rocket, you're looking at the tank.
Yeah.
I'm kind of explaining the part that I worked on. So the tank is like filled with liquid oxygen, and in the case of Starship, methane. In the case of Falcon rocket propellant. Anyways, the way that a tall steel cylinder is traditionally built, typically it's a water tower is kind of the thing that you think of, is you build it sort of like an igloo. You take a sheet of steel, you roll it into like an arc, into a curve, and then you like stack them up next to each other, and then you weld both the verticals and the circumferential welds. This is, again, kind of a nuanced example, but I think this is what you're looking for.
Yeah. We're with you.
Yeah. So the challenge there is that you have a lot more miles of weld, and the vertical welds are particularly challenging from a strength perspective. And so what my team and I developed, was a method by which you use a coil of steel instead of a plate of steel. And imagine you take your coil that's like sitting on the ground as it's produced, you tilt it up, you unravel the coil. That's the circumference of the ring, so to speak. The width of the coil is now the height of the ring. And you chop it, make one vertical weld, and now you save yourself like 8 or 9 welds around. And again, it's like, okay, 1 weld versus 8, great. That's that whole story.
Multiplied by hundreds of rockets a year.
Exactly. Yeah, that whole story went into that, and it's like, but that saved a ton of quality cost, a ton of manufacturing time, a ton of like variability in the process, because welds shrink and you don't know what the circumference is and all that. And so that was like one example of a thing that is, if you wanted to build one of them, didn't matter. That only needed to be incorporated to build many of them.
And do you think, like, to what extent in SpaceX culture, or maybe in, Elon universe culture, does that kind of then loop back to how the engineers make initial designs? Like, how different is SpaceX's engineering culture than, any other? And I guess you've really, you've built your career on this, but I'm curious, like, what your impression is.
Yeah, I think it's meaningfully different compared to other. I've been either around or friends, or, at different companies, or I've worked with other companies for suppliers and that sort of thing. The concept of thinking about the manufacturing and the scale of the product while you're designing it is sort of like, when you say it, it's like, well, of course, everyone should do that. It's obvious. It is very rarely thought about in as much rigor as in Elon companies, right? I was at SpaceX. We've hired a ton of Tesla folks here at Base Power. And it's you can definitely tell the difference between somebody that worked at, name your aerospace or automotive or defense company, and one that has worked at a company run by Elon or Elon acolytes, perhaps. And you can really see the difference in how design is thought about. Cost is thought about. It's a system engineering problem, right? It's like, it's not just, can you make it fast and without a bunch of errors and human labor and at scale, but also, is it the right cost decision? Is it the right product level decision? And I think one of the things that I learned at SpaceX and have tried to spread the gospel of now at Anduril both and Base Power is, as an engineer, you need to think about the system. You can't be isolated in your own little, well, I'm designing that bracket. I don't really care what it's attached to. I don't really care how it interfaces with the rest of the rocket or car or whatever. That is like not an acceptable way to be an engineer, in my view. And I think the world's best engineers are very cross-discipline, very multi-talented, so to speak, on the cost and economic side, in addition to the product and like hardcore design side.
So after SpaceX, you jumped over to Anduril, and it was 2020. This was before defense tech was cool. I relate. I was at Palantir when people protested our offices every single day. I guess the protests are back. But what motivated you? What motivated you to make the shift? How did you end up at Anduril?
Yeah.
Also a portfolio company of ours.
Yes, Anduril is excellent. I say this something sort of similar to SpaceX, which is really had the great fortune to work alongside and for the founding team there. Truly excellent. When I started, it was about 200 people, about the third year of the company, roughly. And by the time I left, it was about 3.5 years later, it was like 2,000 people.
Wild.
In, I think it was like 6 or 7 different states and another country.
What was the biggest headcount growth? Like, what part of the company saw the biggest growth, or was it like pretty universal?
It was pretty universal, I think. There's growth everywhere. Like, my team was a handful of folks, and I think when I left, if you include all of the different sites, it was about 250, 300, something like that. And so, ended up growing quite a bit. But yeah, the reason that I had ultimately made the jump was a fewfold. One was somewhat selfishly or personally, I was getting married at the time, and I was like, it was going to be either her or Brownsville, Texas, and I chose the former, which I'm thankful.
She made her way to Texas eventually.
Yeah, she came back to Texas, but I'll say Austin and Brownsville are not the same. I was looking to make a jump out of Brownsville, and I looked at other opportunities within SpaceX back in California and Cape Canaveral, and was kind of pursuing those, and found the Anduril team, and was just really inspired by their mission and vision to really reshape a legacy industry in defense. I'll say, like, just on a personal note, I didn't serve in the military. I don't have a lot of family that did. And so I didn't have that like necessarily deep, direct personal connection. But through my time there, I realized how important this was to the U.S. and how important a strong defense is to be able to do things like SpaceX is doing.
Did you get into working on military trucks pre or post Anduril?
It was right around the time I was like, military is kind of cool. And then I bought this 1975 troop carrying vehicle. And
you still got married.
Yeah, yes, I did. And she's okay with it, I'll say. Yeah,
good.
She accepts.
What's interesting looking at your career background is you joined SpaceX at this time when engineering was moving into manufacturing. Same at Anduril 2020. That's right. A lot of the early products were, now you got to think about actually building a lot of them.
Yeah.
What were some of the similarities between those companies? What were some of the key differences? And sort of what have you taken with you to Base?
Yeah, look, they're very different industries, but I think a lot of the engineering sort of fundamentals are similar in a way. The high ownership on an individual basis, sort of strong cross-functional nature, as I was mentioning, first principles thinking, and really questioning why something was done the way it has. I think with Anduril, there's a lot more comparative maybe products or companies than there were or are with SpaceX. There's ULA kind of, and the Russians have sort of done their thing, but it's very
not really
sort of, yeah. They still use wood to light the light off the engines and all that. So SpaceX is really kind of pioneering and really, I would say, doing both engineering but a lot of invention, right? Whereas Anduril and it's not meant to be disparaging at all, but is maybe doing more engineering than invention, right? They didn't come up with the quadcopter, but are building the world's best quadcopters and various other, whole fleet of drones for various different defense applications. And they're definitely inventing some new fundamental technical stuff around, AI incorporation into defense use cases. But I think there's sort of less fundamental new physics, as I like to say, with that than there is with SpaceX. And so the difference, to your question, the difference is more around how do you bring this to market? How do you have a regulatory and sort of BD strength that I think SpaceX has, but doesn't necessarily need to have, with the government. I think Anduril is really changing how the government procures and thinks about defense, whereas SpaceX is maybe more closer to PLG, where product led growth.
We're the only game in town.
We're the only game in town, and we're 1,000,000x better than the other game, the one other game in town down the street, which is ULA or whatever. And so I think that drove some differences around how we thought about design, manufacturing, and scale. I think Anduril was very, very focused on how do you bring scaled products to market very quickly. And there was I would say there's a customer use case that is inherent in the design of the product that SpaceX, the use case is get satellite into space. There's less of what does the UI look like? How portable is it? What's the interface look like on the software?
40,000 requirements you're getting handed to from some procurement office.
Totally.
That may not be connected to reality.
Totally.
Yeah,
and I think Anduril gets credit for this, but I think it's worth noting their ability to build not only the technical aspect of the business, which is obviously very impressive, but the BD and government relations and policy aspect of the business has been quite fascinating. And it's something that we're focusing a lot on at Base Power. We're honestly defense and energy, not to preface the future discussion here, but defense and energy are pretty similar in their regulatory structure. Obviously, they're totally different physical products, but the utilities have a cost plus business model. And cost plus is how Northrop, Lockheed, Boeing, et cetera, the traditional defense primes are incentivized to go build hardware. The talent acquisition is similar between Anduril and their defense primes versus Base Power and traditional utilities and that sort of thing. And so it's just interesting to see these parallels amongst two totally different industries, but both have a lot of similarities around how things are designed, developed, and sold into the eventual customer.
Maybe this is a good transition. You've set your sights on, fixing energy in America. That's a big one. But
aerospace and defense wasn't enough.
Why energy? Why now? What pulled you to this problem?
Yeah, maybe sort of stating the obvious, but this is I'll kind of walk you down my sort of thought rabbit hole, so to speak, as I and my co-founder Zach were looking at this problem statement. Energy in the form of electricity is really the foundation of basically everything, right? Of every product in this room, my flight here, the car that you drove here. Every energy is embodied in everything, and it's the foundation of basically all modern life. Okay, that's maybe stating the obvious. So then, if you're able to reduce the cost of energy, you're able to have more abundance of things: transportation, AI, products, services, whatever. And so the first question I and my co-founder Zach were asking is, okay, why isn't energy cheaper? What drives the fundamental costs of energy today? And come to find out, a lot of the cost of energy is in the delivery of the energy. So if you look at, say you buy a t-shirt on Amazon, you pay $10 for the t-shirt. In electricity economics, you also pay $10 or maybe even a little more than $10 in some states for the delivery of that t-shirt. That's crazy. You should be paying for the thing, not the thing getting to you, right? And so we're like, why is that so expensive? And as you continue to go down this rabbit hole of research, what you find is that the kind of what I said earlier, the utilities, the sort of current players in the market that are doing the delivery of the thing, which is electricity, are not incentivized generally to properly and cost effectively deliver that energy. There's not a lot of modern technology built in the stack. The grid was built a very long time ago, as folks know, and frankly, there's not a lot of top talent working on this problem. And so Zach and I were sort of like, this is an interesting problem to solve. what is the right business model to build? And we could talk about that around energy, and we're obviously still building that business model. But I think fundamentally what we're here to do is to solve the delivered, in italics very specifically, delivered cost of energy. Because the cost of generating electricity is going down, and we think that will continue just with like sort of basic iterations on pick your favorite generation source, nuclear, solar, wind, whatever. That will continue to come down the cost curve. The delivery is actually getting increasingly expensive. It is going the wrong way. We want to change that.
Maybe just clicking a layer deeper, distributed energy storage, you talk about transmission and delivery. What exactly does storage provide to the grid? How does it actually reduce delivery fees to end consumers?
Yeah. So the way to think about storage is storage moves energy through time, and the grid moves energy through space, right? So I think the explanation that I love is, imagine in your head you have a line between your nuclear power plant and your home. And that is the grid, this line, right? And the question is, A, do you need storage? And then B, if you do need it, where do you put it along that line? Do you put it on the nuclear power plant, or do you put it on the home? So first, let's answer the first question of why you need storage. The reason is because in the case of the nuclear power plant, sometimes it has to shut down for refueling, or there's certain fluctuations in generation. Now, nuclear actually has one of the sort of the reason I picked it as an example is like one of the smoothest sort of outputs of generation, but wind and solar obviously have more intermittency, but so do coal and natural gas with maintenance and all that. So you need some way to keep powering the thing on the right side of this line, which is the home, while the generation source is down or is a low production.
And the right side, the load, is also fluctuating wildly.
Exactly.
Daily, seasonally.
Exactly. And so if you look at your average home, like right now, unless you have folks at your house, you're probably using like rounding error to zero. Your refrigerator's running, it's a few hundred watts or whatever. You get home, you plug in your EV, you turn on your AC, you turn on your oven, whatever. You are now using an order of magnitude or 2 or 3 orders of magnitude more on a percentage basis than you were right now, right? And so to your point, the load fluctuates. And so the load fluctuates in time, the generation fluctuates in time. You want some way to store energy such that you can smooth out that demand volatility and that supply volatility. Now the second question, first question was, do you want batteries? Check. Yes, we want batteries. We want batteries. Good. The second question is, where do you put them? If you put them on the generation side, now that, say that nuclear power plant instead is a solar farm or is a wind farm, now that you smoothed out the generation part, but you haven't done anything for the grid itself, right? Because when the home is, it's 5 p.m., you plugged in your EV, you started your oven, and you have your AC running, that line still has to transmit the maximum amount of energy. But earlier on in that day, it was totally unutilized. Think about that line as like a highway. The highway has got a ton of traffic on it at 5 p.m., but is totally dead empty at 4 a.m., right? That's an inefficient use of that infrastructure. You'd rather be using it. You'd rather have traffic on it all the time, or at least it be fully utilized. And so this leads to the answer to the second question, was what you'd rather put that storage at the load side, at the home. Because now you can offset the fluctuations in generation, but you can also offset the fluctuations in load. So when everybody else plugs in their EV, turns on their oven, turns on their AC, you're discharging that battery into the home, offsetting that home, basically taking that home off the grid for that period of time and relieving that line to serve the other homes. And then when it's noon and everybody's away from their house, you can charge the battery, putting more cars on the road of the distribution grid, so to speak. So long-winded answer of saying it's a way to utilize the existing infrastructure far, far more effectively. If you look at the average distribution line in the US, its utilization is far below 50%. But the entire system has to be built for peak. Basically, like if you have, Texas has 85 gigawatts at peak, typically during, or at least last summer, the system has to be built for 85 gigawatts. But in October, you might have 45 gigawatts or 40 gigawatts in the middle of the night. There's a ton of extra capacity sitting there. You want storage to fix that problem.
And so, Texas has really become ground zero for innovation on the grid. Can you tell us why that is and why you chose to start Base Power in Texas? Yeah.
Texas is a fascinating place. I spent a lot of time there in Brownsville, but I was not originally from there, but have now found it home. I'll say, just to start with, it's a great place to do business. It is like very friendly regulatory environment, great technical talent and operational talent, It's like the fastest growing state, a ton of population growth. It's like just generally a great economy. That's not the only reason we started, but it's like a great cherry on top as to why building a business in Texas
Austin's a cool city.
Austin's awesome. Dallas and Houston are okay, but Austin's really awesome. So is San Antonio. No, I'm kidding. Austin's great. So why start in Texas for this particular company and this particular problem? Texas is its own physical grid. Some folks might know that. There are 3 grids in the U.S., roughly, west of the Rockies, east of the Rockies, and Texas. So Texas, for all intents and purposes, is not connected into Mexico or either of the 2 U.S. grids. There's some very, very small sipping straws of electricity, basically, to the others, DC ties. And so what that means is that Texas is effectively an island. It's like Puerto Rico or Hawaii or something. And when you have a smaller physical grid, you have more volatility. You can't borrow from your neighbors when you don't have enough, and you can't share access with your neighbors when you have too much. And so that drives volatility, as I described earlier, on demand and supply. The other thing that's interesting about Texas is its regulatory environment, where it allows you to basically be a utility, be a power company, so to speak. Mm-hmm. So the way that works is, and I think a lot of folks probably don't know this unless you live in Houston or Dallas or Austin, is you can choose who you buy your power from. So if you live in a home outside of Houston, you not only can, but you have to choose who you buy your power from. There's like 100 different options. Those are called retailers. The retailers buy electricity from the generators, from the solar farms, wind farms, natural gas plants, whatever. And then they pay the utilities, the grid, to deliver it to their customer, and then they sell it at a retail rate. It's called being a retail electric provider or a rep. Mm-hmm. That is one piece of our business. Mm-hmm. The reason that that's important is because it allows a asset, a device, a battery in our case, behind the meter, meaning attached to someone's home, mm-hmm. To access the wholesale markets directly. So we interface directly with the wholesale markets that are run by a nonprofit organization called ERCOT. It's like, think about them as sort of the air traffic control of Texas electricity, or New York Stock Exchange. And that allows us to monetize the batteries basically immediately. There's still regulatory hoops to jump through and certifications and mm-hmm. all contractor licenses and all this other stuff. But it wasn't and is still a great place to do business to start with. Mm-hmm. We're obviously expanding outside of Texas, but it allows you to sort of be a piece of what a utility typically is, which is sell power to customers and trade directly with the wholesale markets in ERCOT. And I think like on the Texas power stack side is maybe one of the other interesting pieces mm-hmm. here. A lot of folks don't know this, but Texas actually has more renewables than here in California on the grid because they have this free market dynamic around, basically it's called an energy only market. Essentially, it means you get paid for what you produce. And so the lowest marginal cost to produce typically wins. It's basically, for the most part, a free market in Texas.
Solar is cheap.
And solar is very cheap. Now, solar plus batteries distributed on the grid, we think is one of the more effective ways to both deliver and produce electricity. Mm-hmm. But broadly, Texas allows you to basically get paid for what you sell. Mm-hmm. Again, I don't know if folks know this, but literally everywhere outside of Texas, at least in the U.S., they have what's called some form of a capacity market, which is you don't get paid for what you produce. You get paid to be ready to be called on to produce. And that means that the sort of aggregate costs of all the generation are, for the most part, set by this market maker, so to speak. In the Northeast, is called PJM. In sort of the north, further northeast, it's ISO New England. Mm-hmm. And they basically sort of set how much generation is online or ready basically at any one time, mm-hmm. which ends up being a less efficient market than the energy only market that Texas runs, which is like, there's a price, the price changes every 5 minutes. And if the price is above your strike price if you're a natural gas plant, if natural gas, costs you $20 a megawatt hour to generate and prices are 40, mm-hmm. then, you can make the decision if you want to, but generally people will go turn on. And when it goes below, you turn off. Mm-hmm. And it's a much more sort of efficient market that way.
From a technical perspective, you mentioned regulatory component a second ago.
Yeah.
What are some of the challenges of connecting assets to the grid, particularly if you're doing distributed batteries, you're doing sort of a net metering, you're taking power and you're pushing power back to it?
Yeah.
Can you talk about some of like the frequency, voltage? This is a very complicated system. Talk a little about what that looks like as you're designing the equipment.
Yeah, it's a super interesting problem. Power systems engineering is sort of the discipline here that oftentimes is referred to in sort of the context of the question you're asking. The grid was designed and generally built to be a one-way street. It goes from the natural gas power plant to the home. Our view, and we think this is the most efficient way to run a grid, is it's a two-way street, right? You're able to go both directions, like a network as opposed to just a single pipeline. The challenges here are that the grid operator, alongside us, in partnership with us, we have a great relationship with ERCOT, need to be able to manage how much power is going back onto the grid at any one time, both specifically on one location, meaning like if the line connecting your home to the transformer cannot handle that amount of power that you're pushing back onto the grid, you need to know that and control for that. And also the grid operator needs to know where the power supply is happening. The interesting thing about the grid is it's not just one big aggregate machine. It is like a very geographically distributed machine, right? So if you have a ton of power production in one location and a ton of load in the other, you've got a problem. You need like a line that connects the two. And this is actually where batteries come in, is that you can do virtual transmission. You're charging in Dallas and discharging in Houston. You've basically set up a transmission line between those two cities without actually having to build that physical infrastructure. That's another thing that distributed batteries can do. So in terms of frequency and voltage, we have a complex power electronics challenge where we develop both grid forming and grid following inverter. And stop me if this is getting too
Great. Yeah.
So the grid is AC, alternating current, operating at 60 hertz here in the U.S., meaning goes from positive 240 volts, at least at residential voltage, to negative 60 times a second, basically. And if you are pushing power in or out of a line, you might affect that frequency or voltage, and you're also needing to follow the existing grid. So we have a mode on our inverter called grid following, which is basically like, the beat's happening every 60 times a second, and we're following that beat religiously so that we are able to push power and not lead or lag that frequency, basically. Now, at the second the grid goes off, right, these batteries provide backup. Now there's no leader to follow. The grid is no longer there by definition. And so now you have to become the grid in the span of less than, half a second, basically, or some number of milliseconds.
It's like the lights can flicker. That's about
Exactly. So now we have to basically become our own leader and basically create a microgrid within the home. And so this is a relatively hard, both software controls and hardware challenge on the inverter side. And then same thing goes back when the grid comes back online. You might be having a beat that's off beat from your grid. And so now you have to basically sync those two up. So you have to basically turn yourself off, wait for the grid to catch up, turn yourself back on right at the right time, and follow the grid again. This, again, is not an easy technical challenge and something that our power electronics and firmware and software team works on quite a bit. This, among many other technical challenges, transformer sizing, how much harmonic distortion we have in our system. There's a bunch of other really interesting power electronics challenges that you have when you're interfacing with the grid. And then at the system level, we work very closely with ERCOT to say, this is how much power we're going to push out. This is what time, and this, okay, you're okay with us doing that? Okay, great, we'll go for it. There's a lot of coordination involved with the grid operator as well.
And you haven't even touched on the energy trading piece yet, which is a whole other interesting technical challenge.
Yeah, so it's like, okay, so how does the business make money? Maybe is a broad question. One of the revenue sources is energy trading, and it's called ancillary services. And so, as I mentioned, the grid prices change every, in the case of ERCOT, every 5 minutes. That get rolled into a 15-minute price signal. And we, as a storage provider, are responding to those price signals. So when the price is above what we charge the batteries for, well, we might wait for prices to go even higher and then discharge. But anyways, there's like really interesting, almost like, sort of like statistical and quant-based analysis to figure out when to charge and when to discharge. So you're doing price prediction. You're also doing home load predictions. We need to know how much load the home is going to use. And we're also optimizing for our financial risk associated with delivering energy to the customer. So maybe a quick aside here, because we are the retailer, we buy power off of the grid and we sell it at a fixed price. Power price can change. We're selling it to you at, today I think our rate's 9 cents a kilowatt hour, but prices can go to $5 a kilowatt hour. So we need to basically offset our risk of prices going above that 9 cents by using the batteries to take you off the grid when prices are high. And we're co-optimizing those two things, which is a really interesting technical and frankly mathematical challenge that we've got a team of really, really smart folks working on.
I guess I mean, it would be interesting to hear your comparisons working in energy as a retail energy provider, to literal homes and living rooms and kitchens across Texas relative to, building rockets or working in defense. Like, what are some of the major differences, similarities? Like, what have you had to adjust your thinking around?
Yeah, I mean, in defense and in SpaceX's case, obviously there's a customer, but it's a B2G or B2B, go to market, essentially using sort of standard industry terminology. And for us, at least in the deregulated markets, we haven't talked about the regulated markets, which is sort of more of a B2B or B2B2C model. But in the deregulated markets, it's direct to consumer. We need to, and think we've done a decent job so far at building a really strong brand for Texas homeowners. We need to be mindful of, very, very deeply in tune with and responsive to our customer feedback. This is not something that I had prior exposure to for the most part. It has been a fascinating experience to learn how to engage with and excite and motivate a homeowner to go invest in, even though it's a relatively small investment compared to the alternatives, a backup system that we provide, especially because we're about 2.5 years old. We've grown a lot, but we're still relatively new in comparison to the legacy utilities that have been around for hundreds of years. And regardless of what you think about utilities, reliability and all that, they at least have a known reputation. The reputation is known. Our reputation is, for the most part, unknown, or at least we're having it become more known. And so I'd say that's a major difference. The direct-to-consumer aspect of Base Power has been fascinating to learn. My co-founder, Zach, has done a ton of work on this alongside our leadership team and folks we brought over from Starlink, et cetera, on this point. But I've personally just sort of learned a ton about how to sell, market, inspire, and manage the expectations and long-term success and engagement of customers. We call them members, our members throughout the state of Texas. I'd say that's a major difference. Similarity-wise, I think, again, back to this point about defense, defense primes and utilities, basically having a very similar business model. They're both cost plus. They don't attract the top talent, and they also have not put new technology into their infrastructure, into their products in many, many decades. And they're both extremely critical to the U.S. And so, what we like to say, or we think, is energy is one of, utilities in particular, one of the last great undisrupted industries here in the U.S. in terms of the really, really critical ones that underpin a lot of the U.S. economy and a lot of the things that you guys invest behind every day.
Going deeper on that sort of reindustrialization topic, can you talk a little bit about the supply chains for these industries? I mean, everyone talks about aerospace and defense, tier one suppliers. Everyone sees those headlines. Can you talk a little bit about the supply chain on the energy side? What does that stack look like? How are you thinking about it? How do you scale it?
Yeah. It's, I could say rather somewhat unfortunately, maybe somewhat similar to the story on the aerospace and defense supply chains, where a lot of the manufacturing capacity for the raw materials, whether it's, steel or aluminum, all the way through complex end products like battery cells or, nuclear reactor components, doesn't exist in the U.S. anymore. It did previously, maybe not in the case of batteries, because batteries are a little bit newer, but like a lot of that supply chain has not thrived here in the U.S. and a lot of it has gone overseas. And so what you find, particularly for us on the battery side, is that a lot of the components to go build a battery, we build our own modules and our own inverters and such, but we don't make the raw materials, the lithium and the cells, has been offshored, unfortunately. And there's startups, a lot of which you guys are evaluating and or funding, that are kind of working on building the supply chain. But I think one of the things that I've learned throughout my career is it's not sufficient to just have the end producer of the finished good, whether it's an EV or a solar panel or a battery, but you need all of the producers all the way down the chain, down to and inclusive of mining the raw material, in order to have a truly, American domiciled supply chain. So on batteries, take batteries as an example. We make our own modules. That's all custom castings and bus bars and power electronics and such. But we don't make the cells. Cells are something that we buy. the cell technology that we use is called lithium iron phosphate. This is a pretty standard, or at least industry commercialized chemistry. And by the way, LFP was built in the U.S. It was
tragedy.
I know, it's such a shame. We had it. A123 Systems and a bunch of labs out on the East Coast, for the most part, developed LFP many years ago, and then mostly outsourced the manufacturing of it to China, who have then, obviously iterated on it many, many times over and have built a lot of their own IP into it, to be clear. But basically, if you want LFP cells anywhere in the world, you get them from China today. There are a handful of Korean players that are catching up. There's some startups in the US. We've talked to, I believe, every major and minor battery cell manufacturer in the world, and it's very, very difficult to find domestically. And we are working on, and we'll announce, over the next year or so, partnerships that basically bring some of that IP back, and certainly a lot of the manufacturing and domestic supply chain back. But even then, if you're making the cells, where does the lithium, where's the iron, where's the phosphate, where's the separators, where's the cans come from? Those also, that supply chain is mostly overseas, in mostly East Asia. And so this is a really big challenge, and it's something that we're very passionate about solving. We're doing all the final assembly work ourselves. We're doing all the power electronics. All the printed circuit boards are made in the U.S., and so we're trying to build as much domestically, and certainly on the sort of friendly country side as we possibly can. And I think we've gotten basically all of our components either domestic or nearshored. But it's like a real big challenge. You do take a big price hit, and the reindustrialization of America can't come soon enough. We need, not only selfishly for us, all of the supply chain that goes into batteries, but the same thing we saw at Anduril, same thing that SpaceX is dealing with, all the supply chain that goes into Starlink dishes and into rockets, and all the steel and all that all needs to happen in the US.
Maybe cells aside, that's a longer term project.
Yeah.
What any advice you have, for companies that are building within the U.S. supply chain, like how do we get better? You buy a lot of products from different suppliers in the U.S. You have to work very closely with them, I imagine. Like what would be your advice to founders starting companies in this space or working in this space?
Yeah, I think there's a traditional view, which is like, well, you just go to the cheapest supplier and then that's it. And there's a lot of hidden costs associated with going outside of the U.S. that are not maybe obvious up front or part of the contract that you sign with the supplier or the purchase order or whatever, surrounding IP transfer, surrounding logistics timeline, the ability for you to iterate with that supplier, especially if they're making a part that you designed. And my advice to founders is always like, unless there's an extremely, extremely compelling reason to not be domestic, you should start and assume that you probably will want to source things domestically, not because of some like, oh, well, we just want to support the US or whatever. Like at the end of the day, we're building businesses. We need to do the right thing for the business. It's I think actually because it is typically cheaper and far more operationally effective to be local. Like we not only pick suppliers in the US for the reasons that I just outlined, but honestly, we oftentimes try to pick them as close to home as possible. Our printed circuit board suppliers in Austin, as an example, not because we have some like, pride in Austin. We do, but like that's not the reason we selected the supplier. It's because we're iterating very quickly. We're changing designs, especially as we're prototyping.
Down the road.
We drive down the road 20 minutes and we can go directly to the line where the part is being made. It's something I learned at SpaceX, right? It's like co-location of engineering and manufacturing. If they can't be literally in the same building, they better be down the street or at least a short flight away. It really increases your speed to market and your speed to iterate on your product, which for startups, with any company, but in particular for startups, really matters.
Justin, if someone joins Base Power today, what kind of impact do they have in the first year? What are some of the problems they're working on?
Yeah, I'd say they have an enormous impact. We're still a decently, small company, and the way I like to think about the way we onboard and have new folks join us is that they're immediately part of the team. They are, even if you're an intern, you're basically full time from the standpoint of the problem set that you get to work on, and we don't distribute problems, and people don't find problems that are sort of based on, oh, you're new here, so you might do a little thing over in the corner that doesn't really matter. That we don't have time for that. Everybody works on very important problems, because if you're not solving an important problem, you probably should go find one that is more important, right? So it obviously depends on the discipline of somebody joining. but we had somebody recently join who is negotiating very large contracts with suppliers that I just mentioned for our next generation hardware that we're building in the U.S. We had another person that just joined a few months ago that owns the entire factory build out that's happening across the street from our office. That we'll be announcing soon. And they own all the equipment procurement, all the real estate development, all the construction, and hiring all the people that work there, right? These are the types of challenges that we still have. We had another person that joined recently that is building basically our entire internal operations software stack. This is one thing we didn't talk about previously, but we've not only developed the software that runs on the hardware and that controls the hardware from the cloud, but very importantly, all of the operational software to hire, train, manage, and track electricians in the field, that commissions our hardware automatically, that turns our customers into signed deals that we can then take through the pipeline and go through permitting and interconnection and all that. All that's custom software, and we have people that join that work on that own that whole stack. So yeah, huge impact from day one. We're a very lean, hardworking, hard-charging team of folks that we believe are the best in the industry. And many, honestly, myself and my co-founder Zach included, did not work in energy previously. I think this is one unique thing about the company that we're building and the talent that we're assembling is like, honestly, more than half, probably most of the folks certainly didn't work in distributed energy, but they didn't work in energy at all. And I think that model has been actually very helpful for us because we can approach problems with an open mind and not with how they traditionally have been solved. And it's also just a more dynamic and fun environment that way.
So what is your message to an engineer, who wants to work on something meaningful? Like, why should they come work at Base Power?
Yeah, look, energy is the most important problem of our generation. Obviously, I'm biased, but I sincerely believe that to be the case. Especially with recent advances in AI and electrification, the usage of energy in the form of electricity is going from like 1 or 2% per year to 5+% per year growth. This is a really meaningful change. And we believe that the constraint to new industries like AI and EVs and human prosperity broadly is going to be around the cost of energy. And so if you want to work on what we believe is the most important problem fundamentally underpinning all of the other problems that are being solved today on the sort of technical economic spectrum, it's energy. Why work for us if you're looking at energy? I think it's like do the best work of your career with a world-class team. Like I said, we're assembling a team that I believe to be the absolute best in the energy industry. If you want to work at the most dynamic, the most exciting, the best culture, and work with the best people in the energy industry. If we've got you on the energy part, then you want to work at Base Power because we're the sort of best place to work for that. I think the other thing, and this is something that inspires me and is frankly just very interesting to me and kind of why I picked manufacturing as my discipline, at least at SpaceX and Anduril previously, is how cross-disciplinary it is. You're not just working on, making a widget and then selling that widget. That widget could be very important, or you're not just working on just quote unquote an AI model, also extremely important and impactful. But that's sort of like one line of thinking. It's software development, it's manufacturing, it's go to market, whatever. Energy, and particularly what we're doing at Base Power, is this very interesting combo of economic, technical, operational, financial, and policy regulatory related work streams. And while not everyone works on all of them in every role, you get exposed to basically all of these problems. And as an engineer, you're thinking about the regulatory impact of what you can and can't put on the grid. As a salesperson, you're thinking about how you pitch to the homeowner the technical aspects of the hardware. This is not something that you typically do as a salesperson elsewhere. And so the cross-disciplinary nature, fundamental nature of the business, I think really is, frankly, it's very exciting to me, and it keeps me on my toes, and I learn a ton more, building Base Power than I think you would if you were working at a company that was kind of doing one thing. We're doing like a lot of different things across a bunch of different disciplines. That's somewhat inherent to energy and somewhat inherent to how we're building the company. The last thing I'll say is we're based in Austin. We're primarily recruiting there in Austin, and I, as not an original Austinite, have really come to love it. It is a great place to build a family and to live. I think there's like a really interesting sort of like cultural aspect to Austin. There's a ton of interesting, music and nightlife and all that. I don't know, I've personally found Austin to be a great place to live. And I think we're in a special moment now of building deep tech in Austin. There's a handful of us, companies, some of which that you have supported.
Some of which in our portfolio as well.
Some of which are in your portfolio, some of which maybe should be in the future. But Austin is really sort of becoming this hub for deep tech, American Dynamism, pick your sort of, verbiage for it. I've really found that to be exciting. And I think we've had a lot of folks that have moved from the coasts or elsewhere in the country to Austin and have really enjoyed it. And so I think that combined with the other aspects that I mentioned is really the reason that I would work at Base Power.